Welcome back, student. We are studying carbon, and we are studying carbon in a series of lectures. My dear student, we are going to study carbon from 7th standard to 12th standard. The last property which we have learned about carbon was from 9th standard, that is, carbon is a non-metallic element. My dear student, we have also studied electronic configuration of carbon. Today again we are going to study electronic configuration of carbon along with other elements. My dear student, we will study the electronic configuration of element from atomic number 1 to 20 and write the electronic configuration of all these elements, and also consider the electronic configuration of carbon. We will also try to find out some new terminology which we will study in this process and have brainstorming upon the new topic which comes in our discussion. So my dear student, let's study the structure of atom which is given in 8th standard, and also study the electronic configuration of different elements. My dear student, let's study the structure of atom which is given in standard 8. At the center of an atom there is nucleus. This nucleus is surrounded by different shells. My dear student, in 8th standard we have studied the structure of atom. In the center of an atom there is nucleus. So at the center we'll mark nucleus. Surrounding this nucleus there are number of shells. These shells are named as number 1 K, number 2 shell L, number 3 M, and number 4 N. My dear student, the nucleus of an atom is surrounded by different shells. Number first shell, which is close to the nucleus, is named as K. Number 2 is named as L. Number 3 is named as M, and number 4 is named as N. So the nucleus is surrounded by different shells K, L, M, N. The first shell is K, the second shell is L, the third shell is M, and the fourth shell is N. My dear student, when we study the electronic configuration, we all know that the electronic configuration was given to us by Niels Bohr. So here we are going to study the electronic configuration given by Niels Bohr. According to Niels Bohr, the electronic configuration is given by the formula 2n square, where n denotes the number of shells. So let's find out the number of electrons which are present in different shells of an atom according to Niels Bohr. 2 into 1 square is equal to 2 into 1 square is 1. So 2 into 1 is equal to 2. So my dear student, in the first shell, which is named as K, number of electron present will be 2. 2 into, we will write the number as 2. Now here we are going to study the number of electron present in the second shell, which is called as L, shell L square. 2 into 2 square is 2 2s are 4 is equal to 2 4s are 8. So number of electron present in L shell will be 8. 2 into 3 square is equal to 2 into 3 3s are 9 is equal to 2 9s are 18. So number of electron present in the third shell or in the shell M will be 18. 2 into 4 square. 2 into 4 4 the 16. 16 2 the 32. So number of electron present in the fourth shell, that is shell N, will be 32. So my dear student, we have already discussed this. Then what is the importance of discussing it again? We are going to do one activity and I will tell you what was the need for us to again discuss this electronic configuration. So let's start our activity. My dear student, you know that the first element is hydrogen and the atomic number of hydrogen is 1. So according to Niels Bohr atomic theory, or according to Niels Bohr's electronic configuration, the number of electron in the first orbit will be 1. So it is denoted in a bracket. The second element after hydrogen is helium. And you all know, my dear student, the atomic number of helium is 2. So number of electron in helium are 2 and the first orbit has the capacity to have 2 electrons. So we will write here 2 and we will close the bracket. Now we will go to the third element in the series. Hydrogen, helium, then comes lithium. The atomic number is 3. It means that lithium has 3 electrons present in its atom. And according to our theory, the first orbit will have 2 electrons. So we will write first 2. Total 3 electrons is there. One more electron lithium has. So we will put it in the next orbit. And the electronic configuration can be written as 2, 1. The first orbit 2 electrons are there, it is completely filled. The next remaining electron will put in the next orbit. Hydrogen, helium, lithium, beryllium. The atomic number of beryllium is 4. So my dear student, beryllium will have 4 electrons. So the electronic configuration of beryllium can be written as first orbit 2, remaining will go to second orbit 2, 2. From this we can say that the capacity of first orbit, that is orbit K or shell K, is 2, and we have written 2 in first orbit. The second orbit capacity is 8. So we can put 8 electron in the next second shell. Now we will take the fifth element in the sequence: hydrogen, helium, lithium, beryllium, boron. And atomic number of boron is 5, and therefore here we can write the electronic configuration as first orbit 2, capacity over, remaining 3 will put in the next orbit. So the electronic configuration will be 2, 3. Now my dear student, let's consider the next element. The next element in the series is carbon. Hydrogen, helium, lithium, beryllium, boron, carbon. Atomic number 6. So the electronic configuration will be 2, remaining 4 will go in the next orbit. My dear student, the next element will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Now, what is the atomic number of nitrogen? It is 7. So we can write the electronic configuration as 2, and remaining will go in the next orbit, that is 2, 5. The next element in the sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. The atomic number of oxygen is 8, and the electronic configuration will be 2, 6. The ninth element in a sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And what is the atomic number of fluorine? The atomic number of fluorine is 9. So the electronic configuration will be 2, 7. 2 plus 7, 9. And the next element in the sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And the atomic number of neon is 10, and the electronic configuration will be 2, 8. Now my dear student, the capacity of first orbit is 2. So if you observe all the elements and the electronic configuration, you will see that in the first orbit I have written only 2 electrons, because the capacity of first shell, that is shell K, is 2, and so more number of electron cannot be written. So if you will consider all the electronic configuration of all the elements in first K shell, you will see only 2 electrons. Now in second shell, the capacity of second shell is 8 electrons, and again we have started filling the remaining electrons in the second shell, that is L, and here you will see that the capacity of the second shell will also get complete, that is 8 electron, and therefore the electronic configuration of neon is 2 8. Now my dear student, above 8 electrons we cannot include in the second shell. So we will now study the next element and write the electronic configuration. 11th. The 11th element is sodium and its atomic number is 11 and its electronic configuration will be 2, completely fill first orbit, 8, completely filled, 10, 1 is remaining, we will take it to the next orbit. So electronic configuration will be 2 8 1. My dear student, the next element in the series will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Atomic number of magnesium is 12 and therefore the electronic configuration will be 2 8 2. Let's count the number of electron. 2 plus 8 10 11 12. Okay, our electronic configuration is correct. 13. The next element in the sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. Al, and the atomic number is 13. So what will be the electronic configuration? Let's put 2 electrons in the first shell, then put 8 electrons in the second shell, and remaining 3 electrons will put in the third shell. My dear student, the next element will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon. And the atomic number is 14 and the electronic configuration is 2 8 4. Let's consider the next element. My dear student, we are studying in lower classes. We are not in a hurry. We will study the topic again and again in a sequence to get the basic knowledge which is important for us in the future. So the 15th element in a sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, and the atomic number is 15. So let's write the electronic configuration 2 8 5. The next element in a sequence will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. And the atomic number is 16. The electronic configuration will be 2 8 6. My dear student, the capacity of first shell, that is K, is 2. The capacity of the second shell, that is L, 8. And the capacity of the third shell, that is M, is 18. The next element, let's see. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and the 17 is chlorine. And the atomic number of chlorine is 17 and the electronic configuration is 2, 8, 7. The next element, let's study. My dear student, here the next element will be hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. AR. And the atomic number is 18 and the electronic configuration will be 288. Let's count the number of electrons. The number of electrons are 18, 2 plus 8, 10, plus 8, 18. My dear student, according to the procedure which we are using, the capacity of the third shell, that is shell M, here according to the formula is 18. Now my dear student, this is the place where we want to stop and think a while, because from here we are going to study something new which is very important for us. Nineteenth. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and then come potassium, and its atomic number is 19. So my dear student, the electronic configuration according to the theory which we are studying will be 2, 8, 9. Here, because the capacity of third shell is 18, so my dear student, you must be thinking that the electronic configuration will be 2, 8, 9. But this is not correct. The electronic configuration of potassium is different. The next element in the sequence is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and the next is calcium, and the atomic number is 20. So according to the formula, you will think that the electronic configuration is 2, 8, 10 and 10, 20. You will go on adding the electrons in a sequence, because here you have studied that the capacity of the third shell is 18. So by a normal procedure, you will go on filling the electrons in the third shell up to 18, but it is wrong. It does not take place. Then what will be the electronic configuration after argon is different. It will be the correct electronic configuration will be 2, 8, 8, 1. The electronic configuration of calcium will be 2, 8, 8, 2. Let's count the number of electrons in potassium first. 2 plus 8 10, 10 plus 8 18, 18 plus 1 19. Now we will count the number of electrons in calcium. 20. 2 plus 8 10, 10 plus 10 20. You will write in this way, but this is wrong. We have to write in this way 2 8 8 2. So 2 plus 8 10, 10 plus 8 18, 19 20. So my dear student, this is the correct electronic configuration. Now, in order to find out the reason why this is wrong and 2881 and 2882 is correct, we have to again upgrade our knowledge and again study the electronic configuration of the element according to Abou's principle. Abou's principle is very important because Abou's principle is mentioned in 12th standard, or it might be mentioned in 11th standard, which tells us another theory in which the electronic configuration is described, and it is called as Abou's principle. And the Abou's principle is the next electronic configuration which we are going to study, because here we have a doubt. According to the Niels-Bohr theory, an electronic configuration, when we go on arranging up to argon, there is no problem, but when we go to the 19th and 20th element, or above 18, 19, 20, 21, 22 number of elements if we consider, then we see that this Niels-Bohr electronic configuration does not suit to the other elements above 18, or it is not correct. We have to study some more points, so we will keep it Niels-Bohr electronic configuration up to the element argon, and from here the another electronic configuration which we are going to study is the electronic configuration according to Abou's principle. And when we study the electronic configuration by Abou's principle, then we will study a new type of distribution of electrons in different orbit, and which will give us a satisfactory answer for why this is correct method. Now let's study Abou's principle.